So tomorrow in class we're going to be talking about adding and subtracting fractions with unlike denominators. So an unlike denominator means that the two fractions have different denominators. We cannot add the numerators when the denominators are different. The reason is when you have different denominators, that means that the size of the pieces are going to be different. This will not be on your quiz on Thursday. I just wanted to go over this before the quiz because we finished up our lesson today. So this will not be on your quiz, it will be on your test. So how do we add fractions with different denominators? When two denominators are different, we need to find a common denominator. So if we want to find a common denominator for 15 and 10, there's lots of different options that we can use. One thing that we can do is that we can multiply 15 and 10 together to get 150. But if we wanted to use something smaller, 15 and 10 have a multiple that is smaller than 150 in common. So I know that 30 is going to be a multiple of 15 because 15 times 2 is 30. And then 30 will also be a multiple of 10 because 10 times 3 is 30. Another example of a common denominator would be 60. So we can multiply 15 times 4 and then 10 times 6 to get 60. What if we wanted to find a common denominator for 3x and 6x squared? Well, we could multiply both of those together. So if we multiply 3x and 6x squared, we will multiply 3 times 6 to get 18, and then x times x squared will be x to the power of 3. Another common denominator for these two numbers would be 6x squared. We can multiply 3x by 2x to get 6x squared. So that might be a little bit of an easier common denominator to work with. So here we have an example of two fractions that have different denominators and we want to add them. So first we think, well, what is going to be a common denominator for 15 and 10? On the previous page we could use 150, 30, or 60. I chose to use 30 because it was the smallest. So what I need to think about is I need to change these fractions so that they have a denominator of 30. So if I want to scale up 12/15 to have a denominator of 30, I'm going to think, well, 15 times what gives me 30? So I need an equivalent fraction with a denominator of 30. So 15 times 2 is what's going to get me 30. So then I need to do the same thing on top. So if I multiply by 2, 12 times 2 will give me 24. So an equivalent fraction to 12/15 will be 24/30. So now I need to do the same with 9/10. So I think 10 times what gives me 30? Well, 3. And so I need to do the same on top. So I'm going to scale up 9 times 3 to get 27. So 9/10 is equivalent to 27/30. So now I can add 24 and 27 because they have the same denominator. So that means that the pieces are the same size. So each piece will be 1/30 of the whole. That means I divide my pizza up into 30 pieces. Each piece will be 1/30. So if I add the total number of pieces, I'm going to add 24 and 27 to get 51 total pieces. So then I'm going to put 51 over my common denominator of 30. So thinking about 51 over 30, I need to think, is that simplified? Well, right now it's improper, which is fine, but I need to see if they have anything in common, any factors in common. So when I look at these two numbers, I realize, yes, they have something in common. I can simplify 51/30 by 3. They have a common factor of 3. So when I divide both 51 and 30 by 3, I get 17/10, or I could write it as the mixed number of 1 and 7/10. So here's another example involving subtraction with fractions that do not have the same denominator. So looking at 6 and 9, I want to pick a denominator that they have in common. So I can multiply 6 times 9 to get 54, or I could choose something smaller. I chose to use a denominator of 18 for this example. So once I choose 18, I now need to find equivalent fractions for 5/6 and 7/9 that have a denominator of 18. So when I think about my first fraction, negative 5/6, I know that 6 times 3 will give me 18. So I need to do the same thing on top. So if I do 5 times 3, that gives me 15. So this will give me negative 15 over 18. Doing the same with 7/9, I'm going to scale up by 2. So 7 times 2 will give me 14. So now that I have negative 15 and negative 14 as numerators, I can subtract them because the denominators are the same. So now this is my new expression. So then I need to do negative 15 minus 14. I could think about this as negative 15 plus negative 14, which will give me a negative 29. Then I need to put my numerator, negative 29, over my common denominator of 18. Then I think, well, can I simplify this anymore? So I think, do they have any common factors? Well, no. 29 is prime, so I know it won't have any factors in common with 18. So negative 5/6 minus 7/9 is negative 29 over 18. My last problem is a over 2 minus a over 6. So if I want to subtract these fractions, I notice they do not have the same denominator. So first I need to find a common denominator. Then I need to find equivalent fractions with that common denominator. So when I look at these two fractions, I think, well, I'm going to use 6 as a common denominator. I could also use 12, I could use 24, I could use 18, but I'm going to stick with 6. So now I need to scale these up to get equivalent fractions. So I know that 2 times 3 is going to give me 6. So I need to scale up by the same thing on top. What's nice with my second fraction is that 8 over 6 already has a denominator of 6, so I do not need to change it. So now that I have changed a over 2 to 3a over 6, I can now subtract. So below is my subtraction. So if I do 3a minus a, that is going to give me 2a. So now I have 2a over 6. But is that simplified? Well, both of them are going to have a common factor of 2, so if I divide both by 2, I'm going to be left with a over 3, which is my final answer. Okay, see y'all tomorrow. Bye.